this lecture on Newton's laws of motion. Our today's topic is equilibrium of concurrent forces. इस टॉपिक में हम पहले देखते हैं कि किन फोर्सेस को concurrent कहा जा सकता है. So the term concurrent is used for forces which act at same point, तो फॉर एग्जाम्पल अगर मेरे पास एक पॉइंट मास है, इस पॉइंट मास पर एक से ज़्यादा फोर्सेस एक्ट कर रहे हैं. ये एक फोर्स है F1 जो इस डायरेक्शन में एक्ट कर रहा है और ये है फोर्स F2 जो इस डायरेक्शन में एक्ट कर रहा है. These two forces are concurrent because they are acting at the same point. It is possible कि एक पॉइंट पर कई फोर्सेस एक्ट कर सकते हैं. So I can have another force here, say this is F3, I can have another force here F4, I can have another force here F5. So this can go up to n forces. कहीं भी any number of forces can act at a certain point and at the same time. Now the next term is equilibrium. The term equilibrium in physics is a very common term. और इस सिचुएशन में जिस इक्विलिब्रियम की हम बात कर रहे हैं वो ये है कि अगर एक पॉइंट पर एक से ज़्यादा फोर्सेस एक्ट करते हैं और उन फोर्सेस का रिजल्टेंट बनता है जीरो, देन अकॉर्डिंग टू न्यूटन्स लॉज दिस पॉइंट और दिस बॉडी जिस पर कई फोर्सेस एक्ट करते हैं whose resultant is zero will be said to be in the state of equilibrium. So the state of equilibrium of a body is that a number of forces acting on the body cause the resultant to be zero. The direction and magnitude of forces should be such that their net resultant is zero. और याद रखें कि when we add these forces, we add them vectorially. That means we have to add them in terms of their magnitude as well as direction. और vector addition में आपको याद होगा we utilize either triangle law of forces or triangle of addition or parallelogram law of addition of vectors. So those will be the mathematical tools जो हम इसमें इस्तेमाल करेंगे and you are already apprised of that in vector algebra. अब equilibrium जो है, once there is no force acting on a body, that means either the body will be in state of rest or in the state of uniform motion in a straight line. This is again as per Newton's first law. So a body which you see in the state of rest or in the state of uniform motion does not mean कि उस पर कोई force act नहीं कर रहा है. It is possible कि उस पर कई forces act कर रहे हैं, लेकिन जो इन forces का resultant है, say their vector sum F1 plus F2 plus F3 plus F4 plus F5. So it is possible that their vector sum is equal to a zero vector. That way their magnitude and resultant added together makes it zero. अब इस केस को आगे बढ़ाने से पहले we think of two types of equilibrium in physics. One is called as translational equilibrium. Translational equilibrium arises in the motion along a straight line, जिसको हम translational motion कहते हैं, or it could be a curved line. So whenever we have a body moving along a line, that way it is a translational motion. So an equilibrium which occurs in the state of translational motion will be called as translational equilibrium. We have also the possibility of rotational equilibrium. When a body is in the state of rotation, we find that there is a possibility of a rotational equilibrium. अब इसके लिए कंडीशन ये है कि translational equilibrium will be there if the resultant of all forces acting on the body is zero. Or rotational equilibrium will be there if the resultant of torques acting on the body is zero. So the net torque if zero is the condition for rotational equilibrium. Net force if equal to zero is the condition for translational equilibrium. अब हम आगे बढ़ते हैं. We take the simplest case of a single point. When I say a single point, और उस single point पर अगर दो equal और opposite forces act करते हैं, what would be the state? So अगर ये एक force है जो act कर रहा है एक particle पर, it is a force of 10 Newton acting towards right. There is an equal force in magnitude but acting in the opposite direction, say this is also 10 Newton, you will agree with me that the net force acting on this particle would be plus 10 minus 10, क्योंकि direction में ये opposite हैं, so the net force will be equal to 0, which means that this particle will be either in the state of rest or in the state of uniform motion. So this is the equilibrium of two forces. The condition now arises that for the two forces to be in equilibrium, we must have the two forces equal in magnitude but opposite in direction, acting at the same point. So they are two concurrent forces because they are acting at the same point. Now let's come to a situation where we want to cause the equilibrium of three forces. So assume कि यही particle जिस पर दो forces act कर रहे हैं, ये एक force F1 और ये एक force F2, they are acting now not opposite to each other, they are acting at a certain angle theta with respect to each other. So this is an angle theta subtended between them. अब इसको हम अंडरस्टैंड करने के लिए बहुत ही एक सिंपल प्रोसीजर अप्लाई करेंगे. फर्स्ट वी विल फाइंड आउट कि इन दो फोर्सेस का जो रिजल्टेंट है, व्हाट इज दैट रिजल्टेंट व्हिच इज एक्टिंग ऑन दिस पार्टिकल. उस रिजल्टेंट को कैलकुलेट करने के लिए मैंने एक पैरेललोग्राम कंप्लीट कर ली बाय अडॉप्टिंग F1 एंड F2 एज टू एडजेसेंट साइड्स ऑफ दैट पैरेललोग्राम. तो ये बन गया उस पैरेललोग्राम का डायगोनल. और पैरेललोग्राम लॉ ऑफ फोर्सेस आपको याद है that this parallelogram law of forces states that the resultant of two forces being represented in magnitude and direction by two adjacent sides of a parallelogram is the diagonal of that parallelogram which passes through their point of intersection. So ये जो force है, this force I will call as some F3, and this F3 force, or let me call it as F3 dash force. F3 dash force is F3 dash force is equal to F1 plus F2. And what will be the magnitude and direction of this, that we can determine from parallelogram law again. जिसका magnitude होगा, that will be under root of F1 square plus F2 square plus twice F1 F2 cos theta. Theta is this angle between the two. Now as a simple application, अगर दो forces F1 और F2 इस तरह से particle पर act करते हैं, तो actual motion जो particle की होगी, that will be along this direction, the resultant of these two. We want to now cause an equilibrium. What is very simple? Very simple is now कि जिस तरह से हमने earlier case में एक point पर दो equal और opposite forces apply किए, तो equilibrium की state हमने achieve कर ली. Same process we will do here. यहाँ हम क्या करेंगे? We will bring a force. I call this force as F3 force. This is F3 force. Let this F3 force be equal in magnitude to F3 dash, but opposite in direction. When I apply it at the particle O, what will be now? These two will get cancelled out. This cancellation of F3 and F3 dash means that there will be equilibrium now. Now this F3 dash is called as an equilibrant to the forces F1 and F2. That means it nullifies the influence of forces F1 and F2 on the particle O. We can slightly change the mathematical structure of this equation. You find कि जो F3 force है, this F3 force is equal to negative of F3 dash force. Negative is कि इसका magnitude वही है जो F3 dash का है, but direction is opposite. So in this equation, if I place in case of F3 dash in this equation, if I write F3 is equal to negative of, मैं F3 dash की जगह ये substitute कर सकता हूँ. So I can say F1 plus F2 in place of F3 dash. That makes it that the value of F3 vector plus F1 vector, अब मैं इनको transpose कर रहा हूँ to the left hand side of the equation, plus F2 must be equal to 0. So this condition satisfies that how we can explain the equilibrium of three forces. We can say that three forces are said to be in equilibrium if their resultant is 0. In other words, there should be a triad of forces which can represent themselves. That means their magnitude and direction should be such that they form a triangle. That triangle will look like this. That in this triangle we have a situation of this type. तो अगर ये F1 है, ये F2 है, ये F3 है. In other words, we have done something like this कि जिस तरह से हम इन दो के लिए ट्राइंगल लॉ कर सकते हैं तैयार. The triangle law would be कि the two forces in same sense, then the resultant is given by third force in the opposite sense. But today what we are doing now is कि जो ये force F1 है और ये force F2 है, these are the two forces जिनको हमने arrange किया along two sides of the triangle such that they have the same sense. So they are in the anti-clockwise direction. The third force, which we take as F3, is not in the opposite sense, but it is in the same sense. So you will agree with me that this would be the situation that if we have three forces in equilibrium, then their representation, geometrical representation, will be always like this. अब ये triangle जरूरी नहीं है कि एक equilateral triangle हो. It's not compulsory that these three forces should be equal in magnitude. No, they can be unequal in magnitude as well. That way कि जो इनके बीच में angles हैं, these angles is not necessary कि हर वक्त ये angles equal हो. That's only once they are equal in magnitude. So that is one of the possibilities which we can have. Now if I see कि क्या ये काम इस diagram में किया जा सकता है, very simple. देखिए what I do is that I have the force F1, F2 and F3. तो मैं इस F1 को खुद के parallel drag करता हूँ. So here I drag F1 parallel to itself. So this is F1 parallel to itself. Don't change its magnitude. Now I bring F2 such that जो इसका initial point है that touches the terminal point of F1. So I drag F2 like this and bring it here. So this is actually F2 now. ये F2 है. So I bring F2 here like this. So this is F2. I'll say कि अगर हम इसको अब drag करें F3 को, if I drag it like this, तो ये बिल्कुल यहाँ से लेके यहाँ तक टच करें. ये exactly जो F3 force है, ये ऐसे इस पर fit हो जाएगा. So you agree with me कि हमने एक triangle बना ली, जिस triangle में तीन forces, एक जो forces हैं equilibrium में हैं, they'll be forming the triangle in this manner. So this is something like this. अब यहाँ जरूरी नहीं है कि as I said कि angles are equal या magnitudes are equal. This can be any shape of the triangle. Isosceles हो सकता है, equilateral हो सकता है, scalar triangle हो सकता है, या कोई भी triangle. Now our very important tool in dealing with this type of situations is a theorem framed by a French mathematician whose name was Bernard Lambie. We call it as Lambie's theorem. Bernard Lambie, he lived from 1640 to 1750, and around 1679 he formulated the parallelogram law of forces or Lambie's theorem. Lambie's theorem को हम ऐसे state करते हैं that given three vectors in equilibrium, तो अगर ये तीन vectors हैं, this is A, this is B, this is C, such that you can see that they are now framing the similar type of triangle जैसे हमने तीन forces में कहा जो equilibrium में हैं, और we have an angle say between these two A and B opposite to C, call it as gamma, an angle opposite to A, call it as alpha, an angle opposite to vector B, call it as beta. Then we can think of a relation between the three. If I take magnitude of A, divide it by sine of this angle, so we have A divided by sine alpha equal to, we have B magnitude of second vector divided by sine beta, and we have C divided by sine gamma. This way this relation is Lambie's theorem, which is a very useful formulation. इसमें अगर हमें कई बार दो forces हमें पता हो और ये angles पता हो, we can determine the third force. Or I can state the same Lambie's theorem for the case of forces. अगर ये एक force है F1, ये एक force है F2, और ये एक force है F3, such that the angles are, these are the angles So this angle is alpha, this angle is beta, and this angle is gamma. We have again from Lambie's theorem F1 divided by sine alpha equal to F2 divided by sine beta equal to F3 divided by sine gamma. तो ये Lambie's theorem हमारे एक बहुत important utility की है in the formulation of the equilibrium states of a body and determination of some forces. So let's prove it for the case of three forces which we can assume through this triangle have to fulfill this condition. So let's go to prove the Lambie's theorem. So we take up now the proof of Lambie's theorem. Lambie's theorem approved. हम फोर्सेस के लिए भी कर सकते हैं, वेक्टर्स के लिए भी कर सकते हैं. लेट्स टेक थ्री फोर्सेस. तो मेरे पास एक फोर्स है F1, I have a force F2, I have a force F3, or I say these three forces are in equilibrium. Once in equilibrium, they can be shown graphically to be like this. So they form the three sides of a triangle. Let me call this triangle as ABC. अब इस ट्राइंगल में हम क्या प्रूव करना चाहते हैं? We want to prove that magnitude, which is length of this side, जिसको हम BC कह सकते हैं, BC. So that represents magnitude of F1 divided by. तो मैं इस एंगल को अल्फा कह रहा हूँ. अल्फा sin alpha is equal to CA is magnitude of F2 is equal to F2 divided by sin beta is equal to, so ये side है AB, that is F3 divided by sin gamma. This we want to prove. Or remember, the F1 in this diagram is length BC, F2 is length CA, and F3 is length AB. Now the moment I talk about area of a triangle, ये आपको याद है कि area of a triangle is equal to 1 by 2 into base into altitude. Altitude को height भी कहते हैं. Now let me take the area of this triangle by drawing an altitude. So drop a perpendicular from A, point A on BC. This is the perpendicular. तो ये आपके पास है alpha, this angle is beta, and this angle is gamma. So let's find out, call this area as A1. So this area A1 would be equal to 1 by 2 into, I take the base BC multiplied by altitude. तो मैं इस पॉइंट का नाम E रख देता हूँ. I call it as E. So multiplied by AE. This would be 1 by 2 into, so BC is F1 multiplied by AE. Now for AE, I can use the triangle AEC. So you'll see कि in triangle AEC, we have sin gamma. Sin gamma is equal to perpendicular AE divided by hypotenuse, that is AC. So therefore AE becomes equal to AC into sin gamma. So I substitute AE here in place of AE. I write AC sin gamma. So that gives you 1 by 2 into F1 into, so what is now AC? AC आप देखें, so this is AC. AC is magnitude wise F2, so it is F2 into sin gamma. Next, I repeat the procedure. अब मैं इसको ये साइड लेके इस साइड को बेस मान के AC साइड को फिर से एरिया निकाल लेता हूँ. Let me call it as A2. So what A2 would be? It would be 1 by 2 into, consider CA as the base multiplied by, तो यहाँ से एक altitude drop कर लेते हैं. So this is the altitude which I drop on this side. तो ये आपके पास altitude. Call this point as point F. So it will be 1 by 2 into base into altitude. Altitude is BF. So that gives you 1 by 2 into, now you agree CA is F2 multiplied by BF. सो दिस इज BF. अब BF के लिए हम फिर से जैसे हमने यहाँ पर ट्राइंगल AC को यूज किया था, सो आई कैन यूज ट्राइंगल BFA. So in triangle BFA we have sine of alpha equal to sine of alpha is equal to base, that is BF divided by F3, which means BF is equal to F3 into sine alpha. तो मैं BF की जगह सब्स्टिट्यूट कर रहा हूँ F3 into sine alpha. I will get this. Next, I again take up the area of this triangle by calling it as A3. A3. So this would be A3 using now the third side as the base. इसको हम base use करेंगे. So I can write it as 1 by 2 into AB 1 by 2 into AB multiplied by, call this as G. So this is CG into CG. That gives you 1 by 2 into AB. आप देखते हैं AB represents the magnitude of force F3 multiplied by, so that way we have now the value of CG into CG. आप CG की वैल्यू के लिए आप क्या कर सकते हो, the way we did it here. अब आप इस ट्राइंगल को ले लें. So this is triangle CGB, triangle. So in triangle CGB I can find out sine beta. So sine beta would be again equal to perpendicular divided by hypotenuse, that is CG divided by hypotenuse. Hypotenuse is F1. So CG becomes F1 into sine beta. I substitute CG equal to F1 into sine beta. Now thinking कि तीनों एरियाज जो हैं A1, A2 और A3, they are three symbols for the same area. एरिया तो एक ही है, ट्राइंगल का एरिया यूनिक होगा, but we have used three symbols, so they represent the same quantity. A1 must be equal to A2 must be equal to A3. Now putting them equal, I have 1 by 2 into F1 into F2 into sine gamma is equal to 1 by 2 into F2 into F3 into sine alpha is equal to 1 by 2 into F3 into F1 into sine beta. अब यहाँ ये तीनों जो है, they are actually the areas of the same triangle, so they are area of triangle ABC, जो तीन फोर्सेस को तीन साइड्स बना के रिप्रेजेंट करती हैं, जो फोर्सेस इक्विलिब्रियम में हैं. तो if I multiply by, let's multiply, so multiply by, तो इसमें आप देखते हैं कि तीनों में 1 by 2 फैक्टर है, so I multiply by 2 divided by F1, F2, F3. So these factor you will see will cancel out certain quantities. तो जब आप यहाँ multiply करते हो 2 by F1, F2, F3, ये 2 cancel out हो जाएगा, F1, F2 cancel out हो जाएगा, you will be left with sin gamma divided by F3. यहाँ जब आप multiply करते हैं तो 2 will get cancelled out, F2 into F3 into sin alpha, F2, F3 will get cancelled, so this will be sin alpha divided by F1 is equal to, जब आप यहाँ multiply करते हैं 2 by F1, F2, F3, 2 will get cancelled out, F3, F1, so this will be sin beta divided by F2. आप तीनों का रेसिप्रोकल ले सकते हो, that is again another way of writing it. Otherwise अगर आप ऐसे भी लिखते हैं, the result is very correct. So I can write it as F3 divided by sin gamma is equal to F1 divided by sin alpha is equal to F2 divided by sin beta. This result is what we call as the Lambie's theorem, or we have proved it for the three forces F1, F2, F3 which are in the state of equilibrium. So you will have situations which will vary like this. Suppose मेरे पास एक object है, this object is a frame, a scenery. इसको हम hang कर रहे हैं एक thread की मदद से, like this. So these are the two forces. I call it as some tension T1. I call this as T2, which is present in these two strings. Then there is a force here, mg. This is the weight which is acting. Now if these three forces are putting this object in state of equilibrium, हम use कर सकते हैं इस theorem को for determining either the angles are given to you, you have to determine one of the forces, or forces are given to you, you have to determine one of the angles. So that way you should be able to apply it, and while we solve problems on this, this will be something very useful. So what we learned in this lecture was that it is possible that if we have a state of body which is the state of rest or uniform motion, it is possible to exist in such a state in presence of many forces. If we have a particle acted by two forces which are equal and opposite, it will be in the state of equilibrium. But if there are three forces, then the condition imposed on them is that resultant of two forces should be cancelled out or nullified by the third one. That becomes possible if the three forces can be arranged in such a way that they form a closed triangle, and they are represented on that triangle by the three sides in the same order such that their magnitude and direction is represented. If such forces are to be given a mathematical formulation, then we can see that Lambie's theorem becomes something which is a mathematical tool, outcome of the equilibrium. In other words, we can utilize Lambie's theorem for solving problems related to equilibrium of three forces. Limitation of Lambie's theorem is that it is applicable only if there are three forces. If there are more, we have to go to other ways of vector algebra of resolving the problem, which you can see is that the sum total of all forces F1 plus F2 plus F3 plus F4 must be equal to 0 if there are n forces. And then we can resolve these forces into components, add them component wise, x components, y components, z components, and component wise the sum must be equal to 0. That will be the part of problem solving on Lambie's theorem. Thank you.